Hi, everyone. In this video, I'm going to discuss organization of electrons around the nucleus. So recall that all atoms consist of protons, neutrons, and electrons. Protons and neutrons are the most massive particles, and they live inside of the nucleus of the atom. Thus, the nucleus accounts for a majority of the atom's mass. Electrons are very small in mass, and they exist outside of the nucleus. Atoms are held together due to the attraction between protons and electrons. Let's consider an atom, rhenium. Rhenium has an atomic number of 75, and so it has 75 protons. A neutral rhenium atom must have an equal number of protons and electrons, as must any neutral atom, and so rhenium also has 75 electrons. How do these 75 electrons arrange themselves? There are two forces at play. There is the attraction of the electrons for the nucleus. Recall, the nucleus is positively charged, and the electron is negatively charged. And so all electrons are inherently attracted to the positively charged nucleus. However, there is also a charge repulsion between electrons. Electrons repel other electrons because negative charges repel other negative charges. So all electrons want to get as close to the nucleus as possible. However, they want to interact with each other as little as possible. So you need to minimize the distance to the nucleus while also maximizing distance away from other electrons. How do electrons do that? They organize themselves into little houses, little electron houses called orbitals. Each electron has an address. Electrons first organize themselves into shells, with a few electrons squeezing in as close to the nucleus as possible, and even more electrons squeezing into shells further out from the nucleus. There are 7 total shells corresponding to the 7 periods of the periodic table. The first shell, very close to the nucleus, can only hold 2 electrons. The second shell, a little further out from the nucleus, can hold 10 electrons. The third shell, even further out from the nucleus, can hold 18 electrons. And the fourth, fifth, sixth, and seventh shells can all hold 32 electrons each. Notice the further you get from the nucleus, or the further you get away from the nucleus, the more electrons you can hold. And you can kind of see that here. So if we just look at the radius of the n=1 shell over here, which is quite literally a shell, right? We can imagine shells just forming around each other. The radius of this shell is very, very small. And so the sphere that corresponds to this shell is likewise very, very small. The smaller the amount of space, the smaller amount of electrons you can occupy. And this is because electrons repel each other. And so this first shell only holds 2 electrons. If we look into each shell has a specific number of subshells. The first shell only has 1 subshell called the S subshell. Each S subshell can hold 2 electrons. Every single shell, the first, second, third, all the way to the 7th shell, has an S subshell. P subshells are slightly bigger. They can accommodate 6 electrons. Only the second shells and higher have P subshells. D subshells are even bigger. They can hold 10 electrons. Only shells 3 and up have D subshells. And F subshells are the largest. They can hold a total of 14 electrons, and they only exist in the 4th shell and up. So we have 4 different subshells. Each shell has a unique combination of subshells. Larger shells have more types of subshells and consequently can hold more electrons. Within each subshell, you have a different number of orbitals. And now let's look at the organization. So here I have each of the shells from 1 to 4. The n=1 shell is the one closest to the nucleus. It only has an S subshell. Here I've drawn with these tiny little lines the orbitals. An S subshell has 1 orbital, and each orbital can hold 1 electron. So I can annotate here. These little dashes are equal to an orbital. And each orbital can hold 2 electrons each. These orbitals will fill one at a time, filling in order of increasing energy. Low energy orbitals fill first, high energy orbitals fill next. The highest energy orbitals will be the last ones to fill because remember, energy is a measure of stability. Low energy is very stable, high energy is very unstable. S subshells only have 1 orbital, and so they can only accommodate 2 electrons each. Electrons can be drawn as up arrow and down arrows. P subshells only exist in shells 2 and up, and they can accommodate 6 electrons each. Within each P subshell, there are 3 orbitals. If there are 2 electrons per orbital, it makes sense that each P subshell can hold a total of 6 electrons. D subshells only exist in shells 3 and up, and so for each D subshell, we have 5 orbitals. Since they can hold 2 electrons each D subshell can hold 10 electrons. And finally, in shells 4 to 7, we also have F subshells, which contain 7 orbitals and can hold a total of 14 electrons. This rule that I just stated, that electrons will fill in order of increasing energy, is called the Aufbau principle. And as general rules, shells closest to the nucleus are more stable than shells that are farther away. So the n equals 1 shell is the most stable. And that's the one where most electrons want to be. The n equals 7 shell is the least stable. And it makes sense that it's the least stable because it's the one that's farthest away from the nucleus. For each subshell within a shell, let's just consider n equals 4 to 7. These shells contain all 4 different types of subshells. Within a given shell, the s orbital is the most stable, the p orbital is the second most stable, the d orbital is the third most stable, and the f orbitals are the least stable.